I wish to thank the organizers of the 7th World Aging and Rejuvenation Conference for inviting me to give this presentation. I am Dr. Mary Newport and practiced for 30 years as a neonatologist, but I became interested in Alzheimer's disease and the related research when my husband Steve developed the early onset form of the disease at age 51. Steve had a dramatic response to ketogenic strategies, which are the subject of my presentation. Here is an overview of my presentation. For much more detailed information, I encourage you to read my open access article, which is cited on the slide. According to Alzheimer's Disease International, there are an estimated 55 million people currently suffering with dementia, and this number is expected to nearly triple by the year 2050. About 60 to 70% of dementia cases are Alzheimer's. The exact causes are still unknown, although there are likely many triggers, and no drugs have been shown to improve cognition in people with Alzheimer's. While age is the greatest risk factor for Alzheimer's disease, diabetes is a major risk factor, and lifestyle risk factors such as poor diet and lack of exercise appear to account for about 40 to 50% of dementia cases, and therefore Alzheimer's and dementia may be avoidable. Humans have trillions of neurons and other types of brain cells called glia that protect, nourish, and maintain the neurons and nerves. Each of these cell types is affected in Alzheimer's disease, but can also be affected during the aging process to a lesser extent. The classic hallmarks of Alzheimer's disease are plaques and tangles in the brain, which were first described by Dr. Alois Alzheimer in 1906. The beta amyloid plaques can impinge on cells, nerves, synapses, and blood vessels. The plaques tend to appear in the brain in elderly people, but in general, these plaques are more abundant in people with Alzheimer's disease. More than 40 clinical trials of drugs that remove beta amyloid plaques have failed to improve cognition, and some worsen the disease. Other pathologies in the brain may occur during aging, which become much more exaggerated in the Alzheimer's brain. During middle age, the brain begins to shrink a bit each year, and this becomes very prominent in people with Alzheimer's disease. This presentation will focus on the problem of insulin resistance with abnormal glucose uptake into the brain and brain cells. These issues can occur with aging and may begin in middle age, but are greatly exaggerated in Alzheimer's disease. Therefore, even younger adults should start thinking about prevention of dementia as they age. So what if there was a nutritional approach that could help improve symptoms and address the metabolic problems in aging and Alzheimer's disease? In 2005 and 2008, Suzanne Delamonte and Mark Wind at Brown University in the U.S. reported that the brains of people with Alzheimer's who did not have type 1 or type 2 diabetes showed insulin deficiency and insulin resistance, and that this process is present in the earliest stages of Alzheimer's and worsens with each stage of the disease until it is widespread and severe. This slide shows the difference between a normal glucose PET scan and a scan in the Alzheimer brain. The yellow and red areas are areas of high glucose uptake into the brain, and it is obvious that there is much less glucose uptake in the Alzheimer brain. Without adequate fuel, brain cells in Alzheimer's malfunction and may eventually die. This problem with glucose may begin decades before symptoms appear. Cells, including brain cells, require fuel to produce the energy molecule adenosine triphosphate within mitochondria. The brain is only about 2 or 3% of our total body weight, but is an extremely active tissue even while we are sleeping, and requires about 20 to 25% of the energy that humans consume. Neurons can contain 1,000 mitochondria or more to produce the energy they require. Glucose is the predominant fuel for the brain and other organs in people on a typical high-carbohydrate diet, but our metabolism can switch to alternative fuels while fasting when glucose stores are used up. Glucose can be produced from other sources such as amino acids from muscle breakdown, which would be depleted within 1 to 2 weeks. However, we can survive by using fat for fuel. Fatty acids from adipose tissue can fuel most organs, but are not taken up readily into the brain. Fortunately, during fasting, fatty acids can be converted to ketones in the liver, which are easily taken up for use as fuel by the brain and brain cells. Ketones do not require insulin to enter the brain or brain cells and fuel the same biochemical pathway as glucose within mitochondria to make ATP by way of the tricarboxylic acid or TCA cycle and electron transport. There are three ketones produced when fatty acids are metabolized in the liver, including acetoacetate, which is further converted to beta-hydroxybutyrate, the predominant ketone in the bloodstream, and acetoacetate is also converted to acetone, which is mostly exhaled and accounts for the fruity breath that people in ketosis often experience. This is my hero, Dr. Richard Veach, who spent his entire career at the National Institutes of Health in the U.S. and was a world expert on ketones until he died at age 84. Dr. Veach took great interest in helping my husband, and I'm very grateful for the many years he helped us. In the 1990s, Dr. Veach began to study the possible therapeutic uses of ketones and was the first to develop an exogenous ketone monoester, which can rapidly and substantially increase beta-hydroxybutyrate levels. A study in brain cell cultures in 2000 found that beta-hydroxybutyrate is neuroprotective, and a later study found reduction of plaques and tangles and improved memory and learning in an Alzheimer's mouse model. My husband was the first person with Alzheimer's to take the ketone ester in a pilot study in 2010. Dr. Veach's product came on the market as a sports drink in 2018 in the US and in the UK. In a series of hypothesis papers between 2001 and 2004, Dr. Veach and others proposed that ketone therapy could be beneficial in diseases that have decreased glucose uptake into cells, insulin resistance, and mitochondrial dysfunction, including the many disorders that are listed on the slide. Studies have shown that ketones also enter many other metabolic pathways and, for example, have been shown to reduce brain inflammation and reduce oxidative stress through several mechanisms. Dr. Stephen Cunnane and his associates at Sherbrooke University in Canada have focused extensively on ketones, aging, and Alzheimer's disease using glucose and ketone PET imaging. They have shown that ketone uptake is normal in the same areas of the brain affected by Alzheimer's disease, which supports the idea of ketogenic therapies. Cunnane has suggested that some neurons in the affected areas may be lying dormant rather than dead as once believed. You might think of this as a car with an empty gas tank that needs fuel to run again. In 1966, Dr. Theodore Van Italy and his associates discovered that following consumption, medium-chain triglycerides are taken up by way of the portal vein directly to the liver and are partially converted to ketones, even if a meal with carbohydrates is consumed at the same time. MCT oil, or medium-chain triglyceride oil, has been used since the 1960s to treat malnutrition syndromes and for nutritional support in all age groups. Medium-chain triglycerides are present in human milk, and to mimic that, MCTs have been used along with coconut oil in infant formulas since the 1980s. Medium-chain triglycerides are not found in the most commonly consumed vegetable oils and fats. The richest natural source of MCTs is coconut oil, followed by palm kernel oil, which is extracted from the white kernel at the center of the palm fruit. MCTs are also found in the milk fat of mammals, including humans, goats, and cows, and therefore MCTs are present in whole milk, cream, and full-fat cheeses. Coconut oil has long been villainized because it is high in saturated fat. However, most of the saturated fats in coconut oil are the medium-chain fatty acids, shown in blue, and are much more prominent in coconut oil than any of the other animal or vegetable fats shown on the chart. Only milk fat or butter has a significant amount of MCTs. The amount of long-chain saturated fatty acids shown in dark orange and red in coconut oil are in the same range as most other polyunsaturated and monounsaturated vegetable oils. To answer the common question about whether coconut oil increases serum cholesterol levels, Dr. Fabian Dayrid and I performed an analysis of 26 studies of people consuming coconut oil, which was published in January 2025 in Nutrients. Altogether, there were 984 data sets with complete lipid profile results at baseline and at the end of a test oil period. For all study durations combined, there was a small average decrease in total cholesterol of minus 0.13% and a decrease in LDL-C of minus 1.8%, and neither average total cholesterol nor LDL-C increased by more than 0.8% for any study duration. Average HDL-C levels increased by 5.8% and triglycerides decreased by 2.9% for all studies combined, which was consistent for each study duration. There were large standard deviations in many of the studies, suggesting that some individuals may experience a large increase and others a large decrease in serum cholesterol and triglyceride levels, especially during the first 2 months or so. So if there is concern, monitoring the lipid profile may be advised. Using dual tracer ketone and glucose PET imaging in more than 300 young and older adults, Dr. Stephen Cunnane and his associates have identified a brain energy gap in cognitively healthy older adults of 7 to 9% that worsens in mild cognitive impairment to 10% and further accelerates in mild Alzheimer's to 20% or greater. Cunnane has shown in clinical trials that MCT oil can improve cognition in people with mild cognitive impairment and can help fill in the brain energy gap with ketones. Shortly after the Veitch group published their paper on the neuroprotective effects of ketones in 2000, Dr. Samuel Henderson in the U.S. patented the idea that the ketones produced from consuming MCT oil might be adequate to improve cognition in people with Alzheimer's disease. Dr. Henderson developed an MCT oil medical food which was called AC1202 during testing. Nearly 9 of the 20 people tested in a pilot study had significantly improved scores on cognitive testing after a single 40-gram dose of the MCT called tricaprylic acid, compared to when these same people received a placebo on another day. A second study of 152 people showed similar significant improvement at 45 and 90 days in the people who were given tricaprylic acid compared to controls taking placebo, particularly in people who did not carry the ApoE4 gene, the known risk factor for Alzheimer's. Fatty acid molecules are structured as strings of carbon atoms with hydrogen and oxygen atoms attached. Medium-chain fatty acids are from 6 to 12 carbons long, called C6, C8, C10, and C12, each of which have its own unique properties. Most MCT oils contain C8 and C10 or C8 alone, but coconut oil contains all four and is about half C12, which is also called lauric acid. Conversion to ketones is most rapid for C6 and C8, followed by C10, and hours later by C12. Even though the peak ketone levels is lower for coconut oil than for MCT oil, the slow conversion to ketones could make ketones available more continuously to the brain. C8 and C10 are known to cross the blood-brain barrier and can provide an alternative fuel for the brain. C10 has been shown to have anticonvulsant activity and to promote the multiplication of mitochondria, which would increase ATP production. Lauric acid has been shown to potently stimulate ketone production in astrocytes in cell cultures. If this is proven in vivo and C12 is confirmed to cross the blood-brain barrier, this suggests that C12 may have a more direct ketogenic effect in the brain. Lauric acid is also known to be highly antimicrobial to a variety of bacteria, viruses, fungi, spirochetes, and protozoa. C12 has been shown to kill many of the microorganisms such as herpes simplex that have been implicated in hundreds of studies as possible causes or contributors to Alzheimer's disease. Lauric acid represents about 6% of the fat in human breast milk and is known to help protect the newborn from infection. There are many commercial applications for lauric acid and monolaurin as antimicrobial agents in medical and veterinary applications and for use in skin and oral care products, soaps, and disinfectants. Virgin coconut oil is also rich in anti-inflammatory and antioxidant polyphenols and contains a substance that was shown to protect the survival of neurons and suppress mitochondrial alterations in neurons exposed to beta-amyloid plaques. A recent clinical trial reported cognitive improvement in people with Alzheimer's who carried the ApoE4 gene. This slide shows a list of articles that review the many studies of ketogenic diets, MCT oil, and several of coconut oil that have been conducted to date. A press release about Dr. Henderson's studies gave me the idea to use coconut oil for my husband Steve. I will now share my husband's story with you, along with a report of the responses to coconut and MCT oil of 287 other people with Alzheimer's and other types of memory impairment. My husband Steve was diagnosed with early onset Alzheimer's disease at age 54. 4 years later, in 2008, he was declining rapidly, and I learned about a medical food in which the only active ingredient was tricaprylic acid, or C8, and had improved cognitive testing results in nearly half the people with Alzheimer's who received it, both in a single-dose pilot study and in a 152-person 90-day study. These results are feasible because brain insulin resistance with decreased uptake of glucose is a prominent and early feature of Alzheimer's, but ketones can replace glucose in the brain to produce ATP via the TCA cycle. The richest natural source of MCTs is coconut oil, which was readily available in health food stores at that time. Steve was scheduled to screen for 2 different clinical trials a day apart when I found this information, so he had testing the day before and hours after starting coconut oil. For the first screening, he scored only 14 points on the 30-point mini-mental status exam, but needed 16 points to qualify, and he drew the very disorganized clock shown on the slide, which indicated that he was on the verge of severe Alzheimer's. I learned from the USDA food database that coconut oil is about 60% MCTs, including C6 through C12, and estimated that about 35 grams of coconut oil would be equal to the 20-gram dose used in the medical food clinical trial. The following day, he screened for a second clinical trial several hours after receiving 35 grams of coconut oil. He gained 4 points on the mini-mental status exam and qualified for the trial. Naturally, I continued the coconut oil and began to include some in each meal. Eventually, he was taking more than 9 tablespoons daily of coconut and MCT oils. This slide shows the many improvements that Steve experienced during the first days, weeks, and months. Steve often said that he felt like a light bulb came on in his brain the day that he started consuming coconut oil. His clock drawing improved dramatically by 14 and 37 days, which you can see at the top of the slide. Steve was no longer depressed, his conversation improved, and he could finish sentences. He recognized family members again, and his tremors diminished very quickly. By 2 months, he was able to tie his shoes again, and his gait was now normal, and he could run again. Steve had not been able to read for 1.5 years, but at 3.5 months after starting coconut oil, Steve advised me that he could read again. He explained that the words would shake around on the page when he was trying to read, and that the shaking had stopped. Despite reporting that Steve was taking coconut and MCT oil, he was accepted into a clinical trial of a drug that removes beta amyloid from the brain. We were later advised that Steve was on the placebo for the first 18 months. During the first year of the clinical trial, Steve had improvements in his scores by 6 of 75 points on the Alzheimer's disease assessment scale cognitive, and he improved by 14 of 78 points on the activities of daily living test. In 2008, when he entered the clinical trial, his MRI showed moderate to severe atrophy, but 2 years later, while taking coconut oil and MCT oil, there was no further increase in atrophy. Steve was the first person with Alzheimer's to receive a ketone ester developed at the NIH by Dr. Richard Beach in a pilot study, and although he enjoyed nearly 4 better quality years before he began to decline again, Steve did eventually pass away from Alzheimer's in early 2016. After writing a white paper in 2008 about my husband's experience with coconut and MCT oil, I began to receive emails, mostly from caregivers, detailing the experience of their loved ones with Alzheimer's and other disorders with memory impairment. I finally had an opportunity to present these anecdotal case reports in a poster presentation at the Alzheimer's Association International Conference in Amsterdam in July of 2023, followed by publication of the study in April of 2024 in a special Alzheimer's issue of Medical Research Archives, the Journal of the European Medical Society. It is more likely that a person would write to me if they had a positive response than if they had no response. However, many people reported that they saw no improvement. I tabulated from the reports how many people reported improvement, no improvement, or stabilization for at least 3 months. In addition, verbatim phrases from the emails, as shown on the slide, were used to further categorize the types of improvements reported. The ages ranged from 33 to 94 years, with slightly more females, and the breakdown of diagnoses and other conditions reported are shown on the slide. Altogether, there were 288 reports with Steve Newport as the index case. Overall, 89% reported improvement, about 7% no improvement, and 2% no improvement but with stabilization for at least 3 months. Many people reported more than one improvement, and you can see on the slide that about 2/3 of the people reported improvements in memory and cognition, about 1/3 in speech, language, and verbal skills, about 1/3 improvements in social interaction, behavior, or mood, and about 1/4 were able to resume self-care and other activities. Almost 20% reported improvements in physical symptoms, and a small percentage reported improvements in sleep, appetite, or vision. Some people have stayed in touch and have reported sustained improvement for up to 10 years. This also points out that there are many other symptoms involved in Alzheimer's disease beyond memory and cognition that could improve by consuming coconut or MCT oil. Improvement in symptoms, and especially in the ability to take care of one's daily needs, can be very meaningful for people affected by memory impairment, as well as their family and caregivers. In addition to coconut and MCT oils, a ketogenic diet and other ketogenic therapies could address the metabolic issues of aging. There is a wide spectrum of ketogenic diets resulting in ketone levels ranging from 0.5 to 5 millimoles or higher. The strictest versions of the diet are mainly used for people with severe drug-resistant epilepsy and as an adjunct to cancer treatment, with dozens of studies going on currently for various types of cancer. For people worried about cognitive decline, levels above 0.5 millimoles could produce some benefit. Mild to moderate ketosis can be achieved by reducing carbohydrate intake to less than 50 grams per day, while keeping protein moderate at about 1 gram per kilo per day of body weight, since excessive protein can be converted to glucose. A meal or snack with more grams as fat than the combined grams of carbohydrate and protein will support ketosis. Ketone levels will increase proportionately as carbs are reduced and fat is increased in the diet. I highly recommend consuming whole foods, such as in a Mediterranean-style diet, since studies have shown such a diet can be beneficial in slowing cognitive decline and may result in many other health benefits. A whole food ketogenic diet is very adaptable to the foods consumed in most cultures. There are several other strategies that may increase ketone levels, such as overnight fasting for at least 10 to 12 hours and time-restricted eating. Adding MCT oil or coconut oil to morning coffee, meals, and snacks can help sustain a constant level of ketones. To avoid diarrhea, it is important to start the oils gradually, such as with 1/2 to 1 teaspoon 2 or 3 times a day with food, then increase by the same amount every few days as tolerated until reaching your goal amount, possibly between 3 and 6 tablespoons a day or more if tolerated. Adding ketone salts and esters can further boost ketone levels for several hours. Caffeine can provide a small bump in ketone levels, and exercise has been shown to increase blood ketones and nearly triple ketone uptake in the brains of people with mild Alzheimer's disease. The ketone levels achieved through diet or the other strategies listed here are many times lower than in diabetic ketoacidosis, in which there is no insulin available and blood glucose levels are very high. You can obtain an 8-page list of references and full-length articles on studies and reviews on ketones, coconut oil, and MCT oil for Alzheimer's disease and other disorders by going to the Scientific Research Articles page on my website or scanning the QR code. Here are my website address, social media links, and books. Thank you so much for your kind attention to my presentation.